Douglas Brenner Shocks here in Southern California. I'm authorized Öhlins sales and service for both automotive and motorcycle. I think I'm the only one in the country authorized to do that, and I'm exclusively Öhlins. I don't work on anything else. I'm a shock tech, not a guru. I've done this for over 30 years, and also I know it's hard to believe because I am so young and handsome. I've been racing for over 50 years and doing shocks and putting them in my car and seeing in competitive on-track situations what I've done. I'm not sitting on the internet or just on YouTube. I call them on the internet jabberwankers, telling you what to do when they have no real experience with actual racing or with real competitive drivers. So be careful. I also know I'm not going to be an internet sensation, so I make my money selling and servicing Öhlins products. So give me a call if you need service or sales. You might as well buy it from somebody who actually knows inside and out the product and not a internet reseller. I'm as close as UPS, FedEx, etc. If you need service or bring them over. I'm in Southern California. I'm available 7 days a week to serve your needs. So give me a call if you need something, and I can compete with any price on Öhlins products. Any legitimate price you have, I can do the same or better, and you might as well buy it from somebody who knows the product. So let's see what we have this week. So here's what our original shim stack looked like, our default, just for testing purposes, shim stack. And here it is on the dyno sheet. And I've done this shim stack. And this basically is just all sealing shims and the same clamping shim. And you might be surprised, here we go to see, it looks virtually identical. Why don't we just have one size shim in stock, like a sealing shim size, and then a bunch of clamping shims, different sizes. In my dyno video, I said there are things a dyno can't do, and this is one of them. As it turns out, the more shims you have in a stack going from big to small, for some reason, the more mechanical grip you have. I can't explain it, I don't know why. It's better to have a stack of thinner shims with more of them than a thicker stack with less. Don't ask me why, I don't know. Believe it or not, do what you want. But I see these stacks with just one size and then a clamping a lot. So if you're working with a shock that has a limited selection of shims, you're not only limited in designing your valving or your damping the way you want it, but also you're limited in getting more grip. From time to time, I'll get a pair of shocks and I'll see in one valving position, let's say a 0.3 millimeter shim of a certain size, and on the other shock I'll see two 0.15s. Evidently the valver, or whoever did the valving, ran out of one size shim and tried to substitute for another. And in my first valving video I showed you the map for shim equivalents. And now we're going to test it out. So the first thing I did is I put one sealing shim, a 0.3 of a millimeter sealing shim, with a clamping shim that was on that side in compression, and I'm using the same rebound damping for our test shock because I'm just trying to show this one side. And I dynoed it, and here's what we come up with. So there's the dyno sheet with 1.3 millimeter shim. Now let's do the math. Here's the math on how many 0.15 shims it would take to be equivalent to a 0.3 shim, to a single 0.3 shim. And lo and behold, it takes 8 0.15 shims to have the same damping as the 1.3 shim. So basically, the shim stack with 0.15 shims is 4 times as thick as that 1.3 shim. So I put that in, same clamping shim, dynoed it. Look at that, same deal. Stranger than fiction. So one of these aftermarket providers of stuff for shocks, not Ohlins, I don't think, but for other shocks, have their special pistons, and they have valving, and their valving they sell in stages. So they say, well, here's the low speed valving, like usually it's just the ceiling shim or shims. Then they put a small shim in between the next stack and call that stage 2. And then sometimes they have 3 stages. It's low speed, medium, and high speed. And they denote it by putting a smaller shim in between. And I don't understand it. It must be marketing or something. Now, that being said, what they're doing, putting the small shim, sometimes it's a nice option when you just can't get a certain part of your shim stack right. Sometimes this works depending on what you're doing. But to do it as a matter of course and say, here's our low speed, and then you put this little shim in, and here's the medium speed, and you put this shim in, and here's the high speed. It's, I don't know. I think it's bogus, but that's just me. Again, it's just me. So here's the valving that we're doing. This is our normal test valving that I put together just for tests. And then what I did was, you can see here, I put in a 22 millimeter by 0.15 shim in between the 2 ceiling shims and the rest of the shim stack. And it's kind of what they did. I looked to see about what they were doing, and it's not exact, but it gives you an idea. So it's supposed to separate this low speed, medium, and high speed, which is, as I said, I think in my initial valving video, it's subjective. There is really no such thing. It's just where you want it and how you want to describe your shim stack. So here's what I did, and here is what it looks like. So it didn't do anything. It just, I don't know if it's digressive. It's a little digressive. It digressed the shim stack and made the valving less. So if you wanted to do this, just put in lighter valving or a smaller clamping shim. I just don't understand. It didn't hurt anything. It didn't hurt the hysteresis or anything like that. But I just don't understand why you'd want to do it. Okay, let's talk about shim preload. And the shim's a spring, so it's just like spring preload with your suspension springs. When you preload a spring, it takes a little more force to get it to move because you've already put some force in it. With shims, why you might want to have shim preload is to do digressive damping, which I don't use, and this is a digressive piston, and I'll show you how this works. And this is a good example to start understanding preload. You could also use it, there are instances where you have the curve you want, but down at the low speed it just isn't getting the force you want. It kind of you get kind of a progressive type of a curve. And in that case you might want to add a little preload. So there's various ways to do it, and of course Öhlins has the best way. But this, in a digressive piston, all digressive pistons from all the manufacturers are kind of this way. You'll notice that there's a ring, and the center is lower than the side. So what happens is when you put a shim on and you push down in the middle, when you tighten it, it makes the shim flex, which is preloading it, so it doesn't go off right away. It has to overcome that little bit of extra force that's already built into the shim. And what happens then is you see the force initially you have a lot of initial force on the dyno curve, and then it flattens out because on this digressive piston you have 4 ports, and it dumps a lot of fluid once it's open, and that way it takes a lot less force to keep it going. Once you've overcome the initial preload, then it gets way easier for the shaft to move, and you get that digressive damping, a lot of digressive damping. Why is there a ring around here? Well, what happens is if the center goes in, this shim is at an angle. And if you had a port kind of like this, it would be sitting on the inside and it wouldn't really seal on the outside. So you'd get a lot of, you'd kind of be defeating your purpose because you get a lot of bleed past the piston. So that's why they put a ring on it, because the ring seals all the way around. It also, as I've said in some of my other videos, it's great. You want ports as far out as you can. But in this instance, you can't really do it because you got this ring. You can't, you know, the port has to be inside the ring, and the ring can't be all the way out because these are the ports on the other side. If you turn this over, it's the same thing. So you know, you have to have these ports open so the fluid can get through. So, and what you do is you put different shims on here, and you can change the amount of preload. The more shims, the less preload, and you can kind of tune that for what you want. Again, I don't use them, but that's how you do it. So then let's talk about if you want a little preload on a regular piston. Well, there's a few ways to do it. The way the so-called professional shocks do it is they dish the piston. In other words, if you were machining it, you machine an angle in it. And some of these manufacturers have 1 degree and 2 degree pistons, so they have different degrees of slope on the piston. And the reason they do that is, like I said before, if you preloaded this and left these flat, it would stick up at the end, you know. I mean, not that much, but it'd leak. So if you put an angle on the whole piston, then when you push this down, it keeps the angle of the piston. In other words, this side is a little down a little from this side, and it all works out. But that's a big pain, because what happens is you're stuck with that piston. And if you're a shock guy, you know, if you're working on these other pistons, we've all stuck them in the lathe and put an angle on until we get what we want, and then you're stuck with that piston. You can't, you know, you can machine more but not less, and it's just not a very good way to go. And these so-called professional pistons just do that. But Öhlins, leave it to Öhlins to come up with the greatest idea. Now, sometimes you might want a little preload, not to be digressive, but sometimes when you want that bleed open and you have to do a lot of damping, sometimes you get a little progressive curve. You get a little dip at the very beginning. You can't build up enough pressure. So if you preloaded the shim a little, you'd get that little bit of pressure. You'd flatten out that line if that's what you wanted to do. And also further up in the stack you could do it too. So here's what Öhlins did. Very, very clever. So this is a flat surface. Here's the shim. It's sitting flat, right? So we want preload. So what Öhlins does is they have a ring shim. Now this shim is a 0.30 thick, 40 millimeters on the outside and 36 on the inside. So we put this on here. And then what we have is we have another shim that's a 36 millimeter OD shim. And depending on which shim you put here and which shim you put there, you can change preload. For instance, what I have here is a 0.10 shim. This is a 0.30, did I say? So that's 0.20 millimeters of spring preload. And this goes down, you put this on, and it centers this. Now this ring shim, if I can get it there, it can't move, it's captivated. And then what you do is you put another 40 millimeter shim over it, and when you push down, this center goes down more than the outside, and it seals on the ring shim. And you can stack, you know, if you can't get enough, you could stack a couple of these. They're a little smaller ring shims you can put higher up in the stack, and that way you can get a little bit of spring preload. The bottom is flat, you don't have to mess with the piston at all, and you can change your spring preload. Very clever, in my opinion. Okay, now that we've seen how we preload, or how Öhlins preloads, and seen the way other shocks might preload. Let's see what it does. Here's Karloff, our test shock, Franken shock, with our normal valving, or I don't know if it's normal, but it's the valving that I've put in just for test purposes. And there's what it looks like. So now let's see what the ring shim looks like. This is with the bleed open, both with bleed open. And look at that, it looks goofy. It's the same up to about here. And what's happening is the bleed hasn't saturated yet. So it's the same here because it's just using the bleed itself for the damping. And then the shims start opening here. And you can see it takes more force because it had to overcome preload on the shim, and then it digresses a little. And this looks like a so-called professional shock has a special piston that makes this kind of shape. And they have all kinds of shims in, shims out, bleed shims to get this shape. And here we did it with just some ring shims. And you could, if you want this more digressive, you could just change the stack above all this. Now let's see, let's open up, or let's close down the bleed to -10. So here you see, this is the rebound, what happened. The rebound has no ring shim, and you get a little digressive damping when you close down the bleed. But here you can clearly see what happens. The bleed's pretty closed down, so right away, because it takes more force to open that shim because it's already preloaded, the sealing shim, you're showing a lot of force, and then it digresses. And this is kind of digressive damping. I have no use for it. But sometimes these ring shims come in handy. You can use them further up in the stack. They're smaller ones. They're 30 millimeter OD ones instead of a 38 or a 40. They have, I think, 40, 38, 36. They might have a 33. But I see them sometimes up in the shim stack to get something happening that somebody wants. So I guess the point is it gives you flexibility to do what you might want to do. Although I pretty much never use digressive damping. I don't know where I'd use it. Öhlins shocks stay fairly consistent over a wide heat range, and that's because I spend a lot of time with thermodynamics, figuring out what expands where and why. As I mentioned in an earlier video on pistons and valves, most of the pistons and valves are steel or brass and not aluminum, and there's a reason for that. I heated up this standard valving, our standard test valving, to different temperatures, and let's see what happened. So here is at 90 degrees, what I usually warm up my dyno to. Then I warmed it up to 100 degrees, the shocks, little less damping, not much. 110 degrees, little less again. 120 degrees, not much difference, and especially in rebound. So let's take and look at the average graph, which is one thing the average graph can do for you. And we can see it's very nice. It's pretty linear. The damping goes down a little bit, but not much. Let's go to the report. And we'll go to this 90 degrees. The average compression damping at 5 inches is 80.15 degrees. At 100 degrees, it's 77.9. At 110 degrees, it's 76.34. And at 120 degrees, it's 74. So there's like a 6-degree spread at 5 inches of damping, a variance of 30 degrees. Okay, please subscribe, hit the bell. I'm hard on other shocks, but I'm an Öhlins guy because Öhlins is the best, and I just don't feel like selling or working on anything else. And Öhlins is not the best just because I work on them. So I just want to make that clear. I'll see you hopefully next week with my next video. Thanks a whole bunch for watching.